This is the OCR GCSE 9-1 Maths Paper 5 from the June 2018 series, and this paper is a non-calculator paper. Question number 1. Part A. Calculate 3/5 plus 5/8. Give your answer as a mixed number in its simplest form. So, we have the 3 multiplied by the 8 plus the 5 multiplied by the 5 all over 5 multiplied by 8. So, 3 times by 8, that's 24. And then we add on to this 5 times 5, which is 25. And then we divide all of this by 5 times by 8, which is 40. So, 24 plus 25, that's 49. So we have 49 over 40. 40 goes into 49 one whole time, and what's left over is 9. So we have 1 and 9 over 40. Part B, work out 5 times 10 to the 4, subtract 1.6 times 10 to the 3. Give your answer in standard form. Well, we need to write everything so we have the same power of 10. So, we have this 5 times 10 to the 4, and we subtract from this 1.6 times 10 to the 3. And what I can do is rewrite this as 0.16 times 10 to the 4. So now we have the same power of 10. So, 5 subtract 0.16, that's 4.84. So we have 4.84 times 10 to the 4. Question 2. Gemma's solution to the inequality 3x plus 1 is greater than negative 5 is shown on the number line. Is Gemma's solution correct? Explain your reasoning. So, to begin with, let's think about this. 3x plus 1 being greater than negative 5. If I subtract 1 from both sides, we end up with 3x being greater than negative 6. And if I divide both sides by 3, you will find x to be greater than negative 2. Her number line shows that x is less than negative 2. So is she correct? Well, she's incorrect because her solution is x is less than negative 2. Question number 3. Work out for part A, negative 3, 2 plus 5, 7. So, if we work out what this is, we've got negative 3 plus 5, which is 2, and 2 plus 7, which is 9. So we end up with the vector 2, 9. Part B, we've got 3, 4 subtract 2 multiplied by the vector 1, negative 3. So if we work this out, we've got the vector 3, 4, and then we subtract from this 2 multiplied by the vector 1, negative 3. 2 times by 1 is 2. 2 times by negative 3, that's negative 6. So we have 3, 4 subtract 2, negative 6. And if I work out what this is, well, 3 subtract 2, that's 1. 4 subtract negative 6, that's 10. So we end up with the vector 1, 10. Question number 4. Here is the nutritional information for a 110 gram serving of cereal. Carbohydrates 99.4 grams, proteins 9.5 grams, fats 1.1 grams. Emily says that more than 90% of this serving is carbohydrates. Is she correct? Explain your reasoning. So, what we need to do is find out what 90% of 110 is. First of all, 10%, that's given by 11 grams. 110 divided by 10 is just 11. So, we want to find out what 90% is. So 90%, we can multiply this 11 by 9 to get 99. So 90% corresponds to 99 grams. And this is less than 99.4 grams. So therefore, Emily is correct. Question number 5. The table shows the relative frequencies of the results for a football team after a number of games. So the relative frequency of winning is 0.2. The relative frequency of losing is 0.45. For part A, we have to complete the table. So we want the relative frequency of drawing. So that's equal to 1. Subtract this 0.2. Subtract this 0.45. And if we work this out, we get 0.35. So the relative frequency of drew is 0.35. Part B, the team lost 10 games, then they won. How many games did the team play altogether? So the relative frequency between won and loss corresponds to 10 games. So we need to find the difference between this 0.45 and the 0.2. So 0.45 subtract 0.2 is 0.25. This corresponds to 10 games. So if I do 10 divided by the 0.25, I get 40 games. Question number 6. Jack sent 15% more text messages in March than in February. Jack sent 460 text messages in March. How many more texts did Jack send in March than in February? So, if we've got 15% more text in March than in February, in March we have 115%, and that corresponds to 460 texts. And we want to find out the amount of text sent in February, so that's 100%, which we need to find. Before that, we can find out what 1% is. We divide both sides by 115 to get 4. So to find out what 100% is, we multiply both sides by 100 to get 400 text messages. So the difference between these, 460 subtract 400, that's 60. So we have 60 more texts in March than in February. Question number 7 here is the floor plan of a rectangular room. We've got 3 meters by 4.5 meters. Tim buys carpet tiles for this room. Each tile is a square measuring 50 centimeters by 50 centimeters. The tiles are only sold in packs of 10. Each pack costs £20. Tim pays for fitting at a rate of £7.50 per square meter. With any fraction of a square meter rounded up, work out the total cost of the tiles and fitting. So we've got 450 centimeters by 300 centimeters. The reason I'm converting to centimeters is because the tiles are given in centimeters. So we can find out how many tiles we go across and down. So across we've got the 450 divided by 50, which is 9 tiles. And down we've got 300 divided by 50, which is 6 tiles. Which means the total number of tiles we need, 9 times by 6 is 54. So we have 54 tiles in total. Now if tiles come in packs of 10, we've got the first pack 10, second pack 20, third pack 30, fourth pack 40 tiles, fifth pack 50 tiles, and sixth pack 60 tiles. We've got 54 tiles, so what we need then is 6 packs. So we require 6 packs. So therefore we can work out the cost of the tiles. We know that each pack costs £20, so we've got 6 times by 20, which is 120. Now, we know that Tim pays for fitting at a rate of £7.5 per square meter, so let's work out the area of the floor. Area of the floor is 3 meters times 4.5 meters, which is 3.5 meters squared, which is approximately 14 meters. So the cost to fit will equal 14 times by 750, which is 105. So the total cost is £120, which is the cost of the tiles, plus the cost of fitting, which is £105. That gets us £225. Question 8. Hannah wants to display all the possible outcomes when rolling 2 fair 6-sided dice. Part A, give a reason why a tree diagram is not the best method to use. Well, quite simply, there are too many branches. Now, for part B, for the first part, we have to draw a sample space to display all the possible outcomes. So, we have our sample space diagram. For the first die, we've got the faces 1 to 6, and for the second die again, faces 1 to 6. And what we need to do is add the scores. 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5, 1 plus 5 is 6, 1 plus 6 is 7, and we continue this. So we have 3, 4, 5, 6, 7, 8, and again 4, 5, 6, 7, 8, 9, continuing 5, 6, 7, 8, 9, 10, and continuing 6, 7, 8, 9, 10, 11, and continuing 7, 8, 9, 10, 11, 12. We've got our completed sample space diagram. So now we have to show the probability of the scores on the 2 dice adding to 11 is 1 over 18. So we want the scores to add to 11. So we've got 2 of them out of a total of 36. So the probability they add to 11, that's equal to 2 over 36 which is equal to 1 over 11. Question number 9, part A, complete the table for y equals x cubed, subtract 3x. Now here we need to find out what the value of y is when x is negative 1. So let's work out what happens when x equals negative 1. So if we do this, we have y equals negative 1 cubed, subtract 3 multiplied by negative 1. So we have negative 1 plus 3, which is 2. So we end up with 2. So now we have to draw the graph of y equals x cubed subtract 3x for x being in between negative 3 and 3. Well, when x is negative 3, y is equal to negative 18. So if we plot that, so we've got here negative 16, negative 17, negative 18 is over here. Then we've got negative 2, 2, so we've got negative 1, negative 2 is over here. Then we've got negative 1, 2, so that is over here. Then we've got 0, 0. Then we've got 1, negative 2, so that is over here. Then we've got 2, 2, so that is over here. And then we've got 3, 18, which is, well, here we've got 16, 17, and 18 is over here. So now what we need to do is join all of this up. So that is shown here. Now, for part C, use the graph to solve x cubed subtract 3x equals 10. So what we need to do to begin with is draw a vertical line at 10. That is shown here. And then we draw a line down as such. And if we read what we have here, we've got 2.5. So we have x equals 2.5. Question 10. If so, notice this information on her car's dashboard at the end of her journey. She started her journey with a full tank of fuel and her miles travelled set to 0. Now the miles travelled once they start driving is 165 miles and they've used a certain amount of fuel, because it starts off from full and we're going towards empty. Part A, we have to work out how far IFSO's car can travel on a full tank of fuel. So the first thing we'll do, notice that we've got 165 miles, we'll let the total distance equal x. That's the total distance when our car is full of fuel. Now, you can see from here how much fuel we use. Out of 8 parts, we only have 3/8 of fuel which is used. So 3/8 of x is equal to 165, and we need to find out what x is. So x is 165 divided by 3/8, which is 165 multiplied by 8 over 3. So we have 55 multiplied by 8, which is 440 miles. Part B, what assumption have you made when answering part A? Well, the rate of fuel consumption remains the same. Question number 11. The diagram shows two right-angled triangles ABD and BCD sharing a common side BD. AD is 10 centimeters, BC is 12 centimeters, and the angle DBC is 60 degrees. We have to work out the length of AB. Well, if I somehow find out the length of BD, I can then use Pythagoras to find out what AB is. So for us to find out what BD is, let's consider this triangle BDC. We can find out what BD is using cos. We've got the adjacent and the hypotenuse, meaning we have the cosine of 60 equaling BD divided by BC, which is 12. So therefore, if we work out what BD is, BD is equal to 12 cos 60. Cos 60 is a half, so we have 12 times by a half, which is equal to 6. So we've got this length here, which is 6 centimeters. And therefore what we can do is find out what AB is. So to work out what AB is, we can use Pythagoras. So we have AB squared plus this 6 squared, and that's equal to 10 squared. So we've got AB squared equals 10 squared, subtract 6 squared, so that's 64. And therefore, AB is equal to the square root of 64, which is 8. Question 12, Carol says that 64 to the negative 1/2 is 1 over 32. We have to explain her error and give the correct value of 64 to the negative 1/2 in the form P over Q. Well, over here she did not square root the 64. So what we are supposed to do instead, to work out what 64 to the negative 1/2 is, that's equal to 1 over 64 to the 1/2. So square rooting 64, that's an 8, so we end up with 1 over 8. Question number 13, part A, we have to write 5 over 12 as a recurring decimal. Well, 1 over 12 is equal to 0.0833, etc. So therefore, 5 over 12 is 1 over 12 multiplied by 5. So we've got this 0.08333, etc. multiplied by 5. And if we work this out, we get 0.41666, etc. Part B, convert 0.76 recurring to a fraction. So we've got this 0.76 recurring, which I'm going to write as 0.7676, etc. So then, because we've got 2 digits recurring, we can multiply this by 100, leaving us with 76.767676, etc. So what I'll do is I'll let x equal 0.7676, etc. And because we've multiplied by 100, 100x is equal to this. And if I subtract 99x will equal 76. Which means x is equal to 76 over 99. Question number 14. The diagram shows a cylinder and a cone. The cylinder has a radius 2 cm and a height 9 cm. The cone has radius r cm and height h cm. The ratio r to h is 1 to 4. The volume of the cone is equal to the volume of the cylinder. We have to work out the volume of r and the volume v of a cone with radius r and height h is v equals a third pi r squared h. Well, what we can do to begin with is find out the volume of the cylinder. The volume of a cylinder is given by pi times by 2 squared times by 9, which is equal to 36 pi. And we know that if the ratio r to h equals 1 to 4, that means h is equal to 4r. Now we can find the volume of the cone. The volume of a cone is given by a third times by pi times by r squared times by h, and I know what h is, that's 4r. So I have a third times by pi times by r squared times by 4r. So I have the volume of the cone equaling 4/3 pi r cubed. I know that the volume of the cone is equal to the volume of the cylinder, so I've got 4/3 pi r cubed equaling 36 pi, and the pi's cancel on both sides. So if I divide by 4 and times by 3, I get 27 equals r cubed, and if I cube root, r is equal to 3. So I have r equals 3 centimeters. Question number 15. N is a positive integer. We have to prove that 13 n plus 3 plus 3n minus 5 multiplied by 2n plus 3 is a multiple of 6. So we've got this expression here, and I've got this 13n plus 3, and I add on to this 3n subtract 5 multiplied by 2n plus 3, and if I expand and simplify, I end up with 6n squared subtract 10 subtract 15, and if I simplify all this, I've got the 6n squared, and then I've got 13n subtract n, so that's 12n, and then I've got 3 subtract 15, which is negative 12. So I've got 6n squared plus 12n subtract 12, and to show that this is a multiple of 6, so if I factorize out a 6, I've got 6 lots of n squared plus 2n subtract 2. Now, because n is an integer, it follows that n squared plus 2n subtract 2 is also an integer, and because that's the case, we would have 6 multiplied by an integer, which is a multiple of 6, and that's what we wanted to show. Question 16. A, B, C and D are points on the circumference of a circle. PQ is the tangent to the circle at D. The angle BDQ is 72 degrees, and the angle ABD is 63 degrees. We have to work out the size of the angle X. Well, quite simply, this angle X over here will be the same as this 72 degrees here because of the alternate segment theorem. So we have 72 degrees because of the alternate segment theorem. We now have to work out the size of the angle Y. So now that we know what this is 72 degrees, to work out the angle Y, we know that opposite angles in a cyclic quadrilateral add to 180. So we have 72 plus this angle y equals 180. So the angle y is equal to 108 degrees. So we have opposite angles in a cyclic quadrilateral summing to 180. Question 17. X plus a multiplied by x plus 3 multiplied by 2x plus 1 equals bx cubed plus cx squared plus dx. Subtract 12. We have to find the value of a, b, c and d. Well, let's expand as much as we can on the left hand side. We have x plus a, and then x plus 3 times 2x plus 1. That's 2x squared plus 7x plus 3. And on the right hand side, we have bx cubed plus cx squared plus dx. Subtract 12. So let's expand on the left hand side. I've got x times by 2x squared, so that's 2x cubed. X times by 7x, that's 7x squared. X times by 3, that's 3x. A times by 2x squared, that's 2ax squared. A times by 7x, that's 7ax. A times by 3, that's 3a. And what this is equivalent to is bx cubed plus cx squared plus dx minus 12. Now let's group the terms together. We've got the 2x cubed, and in terms of the x squareds, I've got 7 plus 2a of them, then in terms of the x's, I've got 3x plus 7ax, so I've got 3 plus 7a x, and in terms of the numbers, I've got a 3a. And what this is equivalent to is bx cubed plus cx squared plus dx minus 12. Now let's compare coefficients. If we compare coefficients, we've got 2x cubed on the left hand side and bx cubed on the right hand side. So if I compare the x cubed, I've got b equals 2. If I compare the x squareds, I've got 7 plus 2a on the left and c on the right. Can't do much with that yet because I don't know what a and c are. If I compare the x's, well, I've got 3 plus 7a on the left, and I've got d on the right. And if I compare the numbers, I've got 3a over here and minus 12 over here. So let's actually compare the numbers at this point. If I compare the numbers, I've got 3a equals minus 12, which means a equals minus 4. So now if I compare the x's, I've got 3 plus 7a, so I've got 3 times by minus 4, and that's equal to the d. Rather, that's equal to c. So I've got c, let's keep it color consistent, I've got 3 plus 7a equals D. So I've got 3 plus 7 times minus 4 equals D. So I've got D equals negative 25. And if I compare the x squareds at this point, I've got 7 plus 2a equals c. So I've got 7 plus 2 times minus 4 equals c, which means c equals minus 1. So I've got a is minus 4, b is 2, c is minus 1, d is minus 25. Question number 18, part A. A straight line passes through the point 0, 6 and is perpendicular to y equals 4x minus 5. We have to find the equation of this line, giving an answer in the form y equals mx plus c. Well, what we need to do to begin with is find the perpendicular gradient. Well, if the gradient of y equals 4x minus 5 is 4, the perpendicular gradient will be given by the negative reciprocal of this, which is negative 1 over 4. So, our m is negative 1 over 4. Our c is 6, which means our equation of the line is y equals negative 1 over 4x plus 6. Part B, we have to work out the coordinates of the intersection of the graphs of y equals 4x minus 5 and y equals x squared subtract 17. Well, what we need to do is set these equal to each other. So I've got 4x minus 5 equaling x squared minus 17. Let's rearrange. If we rearrange, I've got x squared, subtract 4x, subtract 12, equals 0. And if I factorize, I have x minus 6 multiplied by x plus 2 equals 0. So if x minus 6 is equal to 0, that means x is equal to 6. And if x plus 2 is equal to 0, that means x is minus 2. And what we can do is substitute these into y to find out the corresponding y values. So, when x is equal to 6, y equals 4 multiplied by 6, subtract 5, which is 19. And when x is minus 2, y equals 4 times minus 2, subtract 5, which is minus 13. So, for our coordinates, we've got 6, 19, and then we've got minus 2, minus 13. Question 19. Sarah records the time taken 2 minutes to travel to school for a sample of 168 students at her academy. We have to draw this histogram to represent the information. Well, what we can do is find the class width of each of these. Here we've got 10, here we've got 10, here we've got 20, here we've got 40. We've got the frequency, and with this we can find the frequency density. And we can do that by doing frequency divided by class width. 54 divided by 10 is 5.4. 50 divided by 10 is 5. 44 divided by 20 is 2.2. 20 divided by 40, that's 0.5. So now when we draw the histogram, we need to first of all create our scale. So here we've got 1, Here we've got 2. Here we've got 3. Here we've got 4. Here we've got 5. Here we've got 6. So we've got the first one which we need to draw. That's 5.4 up with the class width of 10, so that's shown here. For the next one we've got 10 and 5, so if I show this, we've got that shown here. Then we've got 2.2 and 20, so 2.2 is over here, and then we've got 0.5 and 40. So that takes us up to here. So here's a completed histogram. So now for part B, Sari says, the longest time that any of these students took to travel to school was 80 minutes. Is she correct? Give a reason for your answer. Well, the problem is here, we've not been given exact data, so it's difficult to tell. So it's difficult to tell because exact data is not given. Now, part C for the first part, Sarah also claims that 25% of all the students at this academy took more than 30 minutes to travel to school. Show how Sarah might have worked out her claim. So, more than 30 minutes. So, what we need to do here is draw a line down from 30 minutes, and we need to work out the areas of this rectangle and this rectangle. So that's this area here. So we've got here 10 times 2.2 plus 40 times 0.5. So let's work out what that is. I've got 10 times 2.2 plus 40 times 0.5, which is 22 plus 20, which is 42. So we've got 42 people who took more than 30 minutes. And therefore, to determine our percentage, we need to do 42 over, now here, the total number is 168. So we need to divide this by 168. And if I work out what this is, I end up with a quarter, which is 25%. We now have to state one assumption that Sarah has made in making a claim. The sample is representative of the whole academy. Question number 20. In the following equation, n is an integer greater than 1. For part A, for the first part, we have to find k when n is 7. So, when n is 7, we have square root 2 to the power of 7. And what this is the same as is square root 2 to the power of 6 multiplied by square root 2 to the power of 1. Square root 2 to the power of 6, that's 2 times 2 times 2, which is 8. So we have 8 multiplied by square root 2. We now have to find the value of n when k is 64. So, one way we could do this is simply by guessing. We've got root 2 to the power of n equals 64 multiplied by root 2. Now, one way we can think about this, when n is 7, we get 8 root 2. When n is 8, we're going to multiply this by 2, so that gets us 16. Well, let's just try n is 10. when n equals 10, we've got root 2 to the power of 10, which is 2 to the power of 5, which is 32. If I multiply this by, if n is 11, we're going to have 32 root 2. Now, let's try what happens when n is 12 then. I would have root 2 to the 12th power, which is 2 to the 6th, which is 64. Now I want 64 root 2, so let's see what happens when n is 13. I have root 2 to the power of 13, which is root 2 to the power of 12, times by root 2 to the power of 1, leaving me with 64 root 2, meaning n is 13. Part B, we have to show that 14 over 3 subtract root 2 can be written in the form a plus b root 2. So, we've got this 14 over 3 subtract root 2, and what I'm going to do is multiply both the top and bottom by 3 plus root 2. So if I work this out, we've got 14 times by 3, which is 42, 14 times root 2, which is 14 root 2. On the bottom I've got a difference of 2 squares, 3 times 3 is 9, and then I've got root 2 times root 2, which is 2, so I've got 9 subtract 2 on the bottom. So I've got 14 plus root 2 plus 42 on the top, and on the bottom I've got 7, so if I simplify this I end up with 6 plus 2 root 2, and that's in the form required.